Today we are going to study calculus. Calculus is a branch of mathematics that deals on limits, functions, differentials, integrals, and infinite series. It has two main branches: differentiation and integration. Limit of a function. Limits describe the value of a function at a certain point in terms of its values at nearby points. What this means is that if f of s is a function, we want to find the value of f of s, maybe at a point A. So at a certain point in terms of its values at nearby point, but not exactly on this A we are referring to. At a point very close to A from the right and very close to A from the left. From the left and from the right. Not exactly on A, but very close to A, both from the right and from the left. We want to find or determine the value of this function. Suppose f is a real function defined at all values of s near A, but not necessarily at A. Let there be a number L such that f of s be as close as you should, provided that s is near enough to A as possible. What we are saying is that f of s approaches L as s approaches A. This is written f of s approaches L as s approaches A, or the limit of f of s as s approaches A is equal to L. Take note of this. We are looking at when s is approaching A, not exactly the point A, as you are going to see from the following examples. Example number 1. Find the limit as s tends to 1 of the function 2s squared minus s minus 1 all over s. Our solution. We have here our 2s squared minus s minus 1 divided by s. Now in this regard, we can then divide your 2s squared by s minus s by s, and then minus 1 also by s. At the end, you now have 2s minus 1 all over s. This will give you, now we are going to take the limit, so therefore the limit of the function as s tends to 1 of 2s minus 1 over s will now be equal to 2 times 1 minus 1 all over 1, because your s is 1. If you simplify this, that will give you 2 minus 1 and the result is equal to 0. The result is equal to 0. If we also decide not to divide through by s each of the terms, and you substitute the value s equal to 1 into the function, you will still get the same result as 0. Example number 2. Evaluate s minus 2 in bracket into s squared plus 3s minus 2 also in bracket all over s squared minus 4 as s tends to 2. So you evaluate the limit as s tends to 2 of that function. Our solution. Observation. If you look at the denominator, it's s squared minus 4. If we take our s to be exactly 2, for example, so we have 2 squared minus 4, which is equal to 4 minus 4, and the value will be 0. And you recall that division by 0 is undefined. So if it is undefined, it therefore means that we cannot continue in that way, but just simply substitute the value of s equal to 2. So we need to factorize and see if any of the factors we cancel out. So we have that our s minus 2 at the numerator, and you have s squared plus 3s minus 2. Everything here all over s minus 2 and then s plus 2, using the difference of 2 squared, because our 4 is the same thing as 2 raised to power 2. So using the difference of 2 squared, we will have the denominator factorized, as you can see it here. Now you realize that the first term here and this term here can cancel. So we are now interested looking at the limit as s tends to 2 of s squared plus 3s minus 2 all over s plus 2. Now this will be equal to 2 squared plus 3 times 2 minus 2 all equal to 2 all over 2 plus 2. The result of this is 4 plus 6 minus 2 also all over 4. And this will give you 10 minus 2 all over 4, and that eventually gives you 8 all over 4, and 8 divided by 4 is equal to 2. So the limit of that function as s approaches 2 or tends to 2 is equal to 2. And this is the result of the evaluation. Example number 3. Evaluate the limit as s tends to 1 of the function s squared minus 1 all over s squared plus s minus 2. Our solution, once again you observe that if you make s to be equal to 1, the denominator, our s squared plus s minus 2, will be equal to 1 squared plus 1 minus 2, which is equal to 1 plus 1 minus 2, and the value is equal to 0. You first of all do this to make sure that the denominator is not 0, because division by 0 is not possible. So now that we have found out that the denominator is equal to 0, what do? We try and factorize if any expression is factorizable. As you can see, we can factorize s squared minus 1 all over s squared plus s minus 2 to be equal to our s squared minus 1 is the difference of 2 squared, which means we apply s squared minus 1 squared, everything here all over s squared plus s minus 2. And of course, the numerator becomes s minus 1 and then s plus 1. And then everything here will be divided by your s squared plus s minus 2. Now let's see how we can factorize this. It's possible to factorize this. Let's look at this. This becomes s minus 1 and then s, let's say what would this be? S plus 2. Good. So we have factorized both the numerator and the denominator. Now s minus 1 and s minus 1 will cancel, leaving you with s plus 1 all over s plus 2. So we will determine the limit of this function now as s tends to 1. So therefore, the limit of the function s plus 1 all over s plus 2 as s tends to 1 will now be equal to 1 plus 1 all over 1 plus 2. And that is equal to 2 all over 3. So the limit is 2 all over 3.